theory of Fraunhofer diffraction of single slit, double slit and multiple slit. Right? So now we will solve some numerical problems related to Fraunhofer diffraction. In this session we solve 5 numerical problems together. Then I will give you one extra question as homework. Okay? Before moving to the problems, we need to understand some equations based on Fraunhofer equation, Fraunhofer diffraction. So, the main equations related to single slit diffraction is condition for minima, is A sin theta is equal to n lambda. Then the condition for maxima A sin theta is equal to 2n plus 1 lambda by 2. Then the next equation is width of central maximum. Width of central maximum is W is equal to 2 lambda f by a. These equations were already discussed in the previous session, so it's just a quick recap. The next is double slit. The equations related to double slit. First, condition for minima. Condition for minima is D sin theta is equal to 2n plus 1 lambda by 2. Then condition for maxima D sin theta is equal to n lambda. The next equation for fringe width. That is beta is equal to lambda f by d. Then the equation for multiple slit. Multiple slit or diffraction. Okay, the equation for principal maxima, condition for principal maxima is D sin theta is equal to n lambda. Here D is equal to A plus B. A is equal to slit width and B is equal to opaque space. Here D is the sum of slit width and the opaque space. Now we reviewed all the equations. Then by using this equation, let's do some problems. Okay? Problem. Light of wavelength 5000 angstrom falls normally on a slit of width 20 into 10 raised to minus 5 centimeter. Calculate the angular position of the first two minima on either side of the principal maximum. Okay, in this question, first write the given data. Here, wavelength lambda is equal to 5000 angstrom. Okay, then the slit width A is equal to 20 into 10 raised to minus 5 centimeter. Here we want to calculate the angular position of first two minima, that is theta 1 and theta 2. Theta 1 when n is equal to 1 and n is equal to 2. We want to find theta 1 and theta 2. We know the condition for minima in the single slit diffraction is, condition for minima single slit diffraction is A sin theta is equal to n lambda, right? So we want to find sin theta, that is an angle. So sin theta is equal to n lambda by A. This is the equation. Okay. First we want to find theta 1. Theta 1 is equal to sin theta 1 is equal to sin theta 1 is equal to, we know in theta 1 n is equal to 1. Then 1 into lambda is 5000 converted into centimeter, that is into 10 raised to minus 8. Okay, then divided by 8. A is 20 into 10 raised to minus 5 centimeter. 20 into 10 raised to minus 5. Then we got 0.25. Sin theta 1 is equal to 0.25. Then theta 1 is equal to sin inverse of 0.25. That is 48 degree. Okay, this is the value of theta 1. Then we want to find theta 2. Sin theta 2 is equal to, n is 2. 2 into 5000 into 10 raised to minus 8 divided by 20 into 10 raised to minus 5. Here we got sin theta 2 is equal to 0.5. We want to find theta 2, then theta 2 is equal to sin inverse of 0.5, that is 30 degree. Okay? Clear? Clear? So now we are moving to the next problem. Write the problem. A convex lens of focal length 50 cm placed near a rectangular slit with 0.2 mm produces a Fraunhofer diffraction on a screen. Wavelength of light used is 5893 angstrom. Calculate the distance of dark band from center to bright. Okay? In this question, we want to calculate the distance. This is theta, this is focal length. Okay? We want to calculate this distance taken as y. Okay? Distance from minima to central maxima. We want to calculate this distance y. Okay? First, write the given data. F is equal to focal length. Here focal length F is equal to 50 centimeter. That is 50 into 10 raised to minus 2 meter. Right? Then given the slit width. then the wavelength lambda is equal to 5893 into 10 raised to minus 10 meter. It's the given data. We know we know the equation y is equal to lambda f by a. Then just substitute all these values into this equation. Then we got y is equal to lambda 5893 into 10 raised to minus 10 into focal length 50 into 10 raised to minus 2 all divided by a. 0.2 into 10 raised to minus 3. By calculating, we got y is equal to 1.473 into 10 raised to minus 3 meter. Okay, this is the second question. Then we are moving to the third problem. A lens whose focal length is 40 cm forms a Fraunhofer diffraction pattern due to a slit 0.3 mm wide. Find the distance of first secondary maximum from the central maximum. The wavelength of light is 589.3. Okay, so in this question we want to calculate the distance from first secondary maximum. Okay, this is the first secondary maximum. This is the central maximum. We want to find this distance taken as x. You know this is focal length. This is the angle theta. This is focal length. Okay. We know the condition for maximum, that is a sin theta is equal to 2n plus 1 lambda by 2. Okay, that is we know in this question mentioned find the distance of first secondary maximum. First secondary maximum is n is equal to 1. Okay, then a sin theta is equal to 3 lambda by 2. This sin theta is equal to 3 lambda by 2a. Assume sin theta is approximately equal to theta, then theta is equal to 3 lambda by 2a. Taken it as equation number 1. Okay, then we want to find the distance x. We know the angle is equal to arc by radius. Arc by radius. Here angle theta is equal to arc is x by f. So we want to find x. So write the equation into x is equal to f theta. This is equation number 2. Then substitute equation number 1 into 2. Okay. So theta is equal to x is equal to f into theta is 3 lambda by 2. 3 lambda by 2. Then substitute all the given values into the equation. Here f is 40 into 10 raised to minus 2. Then 3 into wavelength lambda is 308.93 into 10 raised to minus 9. All divided by 2a. Slit width a is 0.3 0.3 into 10 raised to minus 3. By calculating, we got x is equal to 1.1786 into 10 raised to minus 3. Okay. Any doubt? Okay. Now we are moving to the fourth problem. That is, in a double slit experiment, a slit separation is 0.3 millimeter and monochromatic light of wavelength 600 nanometer is used. If a bright fringe is observed at an angle of 0.002 radian, find the order of the maximum corresponding to this fringe. That is the question. Okay. So first write the given data. Here D is equal to 0.3 into 10 raised to minus 3 meter. Then wavelength lambda is equal to 600 into 10 raised to minus 9 meter. Then theta is equal to 0.0023. Okay. We know the condition for maximum. D sin theta is equal to n lambda. The question is to find the order. So n is equal to d sin theta divided by lambda. Okay, consider sin theta approximately equal to theta. Okay. Then we can write n is equal to d theta divided by lambda. Here n is equal to d is equal to 0.3 into 10 raised to minus 3. 0.3 into 10 raised to minus 3. Theta is 0.002 radian and lambda is equal to 600 into 10 raised to minus 9. Then by calculating this we got 1. That means the order is equal to first order maximum. Okay, it's a simple problem. Then we are moving to the final problem. That is, consider a grating of width 5 cm with slit width A is equal to 0.001. A is equal to 0.001. Then separated by a distance of 0.002 meter. That is, B is equal to 0.002. How many orders would be visible at lambda is equal to 550 nanometer? Okay. Here also we want to find the order. So we know for grating A plus B sin theta is equal to n lambda. Okay. So here we want to find the order. So rearrange the equation. N is equal to A plus B sin theta divided by lambda. For theta is equal to 90 degree, we can write n is equal to A plus B sin 90 is 1 divided by lambda. So here what is A plus B? 0.003 divided by the wavelength lambda is 550 nanometer. Nanometer is converted into centimeter by millimeter by multiplying it with 10 raised to minus 6. So by calculating this, we get n is equal to 5.45. That means the maximum number of observable orders are 5. That's the final problem. Then I give one homework question. That is Fraunhofer double slit diffraction pattern observed in the focal plane of a lens of focal length is 0.5 meter. The wavelength of incident light is 500 nanometer. The distance between two maxima adjacent to the maximum of zero order is 5 nanometer. And fourth order maximum is missing. Find the width of each slit and distance between the